So we're going to start with cosecant. That is the reciprocal of sine. So I'm going to start by drawing sine, right? And then fill in this stuff over here. The period, what would the period be? 2 pi. Because it's 2 pi for cosecant and it doesn't change, so it's 2 pi. There is a phase shift. Which direction do I go? Right, pi fourths. Good. And then vertical shift down 2. So my midline is y equals -2. So just like when we did the other ones, I'm going to sketch in my midline as if it was an asymptote, but it's not. But it's just important for me. It's like my new x-axis. And if I just pretend like that is the x-axis, this part takes care of itself. Okay. So for sine, which I'm not graphing sine, I'm graphing cosecant. But these 3 points that were intercepts are now going to be asymptotes, right? So I had an asymptote at x equals 0. However, I have a phase shift to the right pi fourths. So pi fourths is 1 space away. Now that's not true for every single graph ever, so always check your scale. But it's true. Now I have, that's the beginning of the period. The next thing I want to do is the end of the period over here. Period is 2 pi. So I can go to 2 pi, and then I can go to the right, pi fourths. There's the end of the period. The next thing you should do is the middle. It's an asymptote also. So there's the middle right there. Okay. So the next thing I have then are these 2 points, which those are the same points I would plot for sine. I'm also going to plot for cosecant. I just use them differently. So here for sine, I'd go halfway in between. I know I go up 1. There is no amplitude for the reciprocal functions. That's why it doesn't ask you. But it does, we still do have like a vertical shift, a vertical stretch or compression possibly, and we don't. So 1 is our important number here. So halfway in between these 2 from the midline, I'm going to go up 1. And then halfway in between these 2 from the midline, I go down 1. And then cosecant's been turned inside out. So it looks like this. Okay. Everybody okay with that? Yes, sir. That 1 is like the number that's here. So it's like your vertical stretch or compression. It's the amplitude, but there's not an amplitude. Yeah. Because it's still a number I need to know. That's how I know how far up I go. Good. Anything else? Okay. So then means I need to put another asymptote here, another asymptote here, and halfway in between. So it looks like this. I'm not going to make you put arrows on the asymptotes because I know you're having to draw like 5 million of them. You can if you want to, but you do need arrows on the other parts of the function. Okay. Any questions at all? Well, from this first asymptote, it's 2 pi away. But if I go to actually 2 pi, and then I can go to the right pi fourths. Does that make sense? The distance between these 2 is 2 pi. Well, I shift pi fourths from 2 pi, though. Is what if I'm here, which is where it should be without the shift, right? Like without the shift, I'd have an asymptote at 2 pi. No, not from here. Like if nothing got shifted. If nothing got shifted, the end of my period would be at 2 pi, right? But because of the shift, it gets shifted over. Does that make sense? Is that what you're asking? Okay. All right, anything else? Okay, let's look at the next one. So this is secant, which is the reciprocal of cosine. So I'm going to sketch a cosine here. And what's the period for this one? 3 pi over 4. Good. Now, does everybody know where we're getting these from? These magic numbers. Speak now if you do not. Okay. So phase shift. I'm going to go to the left pi, right? I'm going to go up 1. So my midline is at y equals 1. So y equals 1. Sketch that in. Okay, so for cosine, if I was graphing cosine, I would start at 0, 1. Okay, here, it doesn't ask me about amplitude because there is no amplitude for secant, but there is a vertical stretch of 2, and that's important for me. So now I would really be at 0, 2. You agree with that? But your 0 is from the midline, right? So from the midline, when x is 0, I go up 2. But then I also have a phase shift. I have to go to the left, pi, and that's where that point comes from. Everybody get with that point? Then I need the end of the period. The period is 3 pi fourths. So from this point, or I could go from 3 pi fourths, it doesn't matter. From this point, I'm going to go to the right, 1, 2, 3 pi fourths, and make a point. So now I have these two taken care of. Just like I would for cosine, halfway in between the two, I'm going to get this point. So halfway in between the two is right here for my x value. I'm going to go 2 down from my midline, and I'm right there. And I've got that one taken care of. Okay, everybody good with that? So now I got to get the asymptotes in. The asymptotes are here where it would have been 0, right? And they're halfway in between also. So halfway in between these two, so this is like 1.5 spaces, right? So that's like 0.75 or 3/4. So from this whole point, from this one that's on the line, I'm going 3/4 of the way this way, and I get that done. And from this one, I go 3/4 of the way this way, and get that one done. And then it gets repeated, okay? And that's the important thing to understand here, is that it's getting repeated. So you see how the asymptotes are on either, they're close to the line that's on either side of that point that's in the middle. That's going to continue every time. So you don't have to get confused about your asymptotes and, you know, how far off they're going to be or whatever. So for these points up here, you've got 1, 2 spaces in between. So you can make all of those points. And then also the asymptotes are in the same box that's close to that one, right? So it's going to look like this. So this point's here. And you just continue the pattern. Clearly the air got shut off. No, they don't have a clue. Well, at least that's what they told me in the hallway, so I don't know if that's true, but I don't know, because the weather's not bad. It was just weird. Okay. So when you get all those thousands of points and asymptotes in there, I don't know if that made it better or worse doing it in 2 colors, but any questions? Just count on the graph. Count, skip count. I mean, it's all very repetitive. Okay, well, let's look at cotangent. Now, for secant and cosecant, I think drawing the sine and cosine little parent functions is way better than trying to draw the other ones because they look so much alike. But for cotangent, I think it's good to actually draw cotangent because it's better than tangent. So cotangent has an asymptote here, one here, and then it goes this way, right? So that's what your cotangent looks like. Whereas tangent, we're like drawing pieces of it. If you want to do tangent and then figure that out, that's fine. But I think here this makes it a little bit less confusing. So for this cotangent graph here, what is the period? Pi halves, because for the parent function it's pi, so pi halves, so we get from there. We have a phase shift, we're going to the right 3 pi halves. We have a vertical shift down 3, so y equals -3. And I don't have a vertical stretch or compression, so 1 is my magic number here too. And draw that in. Okay, so for cotangent, because remember this is my actual cotangent, at x equals 0, I have an asymptote. So I should have an asymptote here, except that I have a phase shift to the right 3 pi halves, so that's where that first asymptote actually goes. The period is pi halves, so this other asymptote goes at the end of the period. Pi halves is 2 of those spaces. There's the end of my period. Okay, everybody okay with all that? The next thing I would do would be the middle, which is an intercept. Except now it's the intercept on my midline, right? So it's right here. There are no reflections. So these are the next 2 points that I would do. The y values are dictated by this and your midline, because we're going from the midline now, not the x-axis. So halfway in between here, I go up 1, and halfway in between here, I go down 1, like so. It looks like a domino. And then lather, rinse, repeat, right? Then I have asymptote every other line. All right. Any questions at all? Are we good? Okay. So once you're done, you agree with me, you don't have any questions, nobody has any questions, you can go ahead and glue or tape this in.